Okay, hi everyone. So let's start off today's lesson. We are going to be working with arcs and angles formed by intersecting chords, secants, and tangents. Now, this is some vocabulary I want you guys to remember, as I will be referencing it a lot during the video. So chords, if you remember, are inside the circle, going from edge to edge, right? So both of these are chords. Secants are the ones that go beyond the circle, like lines. And then tangents are the lines that just touch the circle at one point. Okay? So let's go ahead and get started with this lesson. And I think I might just make this video just this page, so that the next one can be, it's the same topic, but it's like a different version of the topic. Anyway, let's get started. So when chords, secants, and tangents intersect in a circle, figure 1, on a circle, figure 2, or outside of a circle, figure 3, special relationships exist between the angle and arc measures formed. So for So if you have two secants or chords intersecting inside a circle, then the measure of the angle is formed is equal to half the sum of the measure of the intercepted arcs, and that's a very simple formula. So measure of angle 1 is going to be 1/2 the measure of arc AD plus the measure of arc BC. Okay, and let's look at what that means here. So measure of angle 1, I'm locating angle 1 right here, is 1/2 of the measure of arc AD, which is right opposite that angle, and plus the measure of arc BC, which is also opposite on the other side of that angle. And then likewise, if I'm trying to find the measure of angle 2, it's 1/2 the measure of arc AB plus the measure of arc CD. And so it follows the same pattern. So measure of angle 2 is here. 2 is right here. That means we are going to add up its opposite angle and the other opposite angle, and then divide it by half in order to get that inside angle measure. So let's put that into practice with question number 1. We are asked to find the measure of angle AED. So this angle E, we need to know the measure of. So I am going to look at its opposite arc AD and the other opposite arc BC. So let's set that up. So, oh, that is not a pen. So the measure of angle AED will equal 1/2 its opposite angle plus the other opposite angle. And this is why we had the algebra review previously, because in order to get rid of this 1/2, I can go ahead and multiply this entire thing by 2. That means I have to multiply this side also by 2. So 2 of angle E equals 45 plus 100. Oh no, I'm sorry. What am I doing? I'm overcomplicating it. I'm sorry. I could just go ahead and solve this part here. My mistake. So because measure of angle AED is already isolated on the left side, all I have to do is add 45 plus 109. So 109, and then divide that by 2. I get 77 degrees, and that is my final answer. Sorry for that confusion. I did not want to start the video again, so let's just pick it up from here. Okay, so looking at question number 2, we have to find the measure of angle STR. So STR means we are trying to find this angle right here. So I'll just call it X, even though I can write measure of angle STR. So the setup again is very similar. X equals its opposite arc plus its other opposite arc, and we divide that by 1/2. So X equals 1/2 112 plus 186, and that will give us 1/2 times 200 98, and x equals 149 degrees. All right, let's keep it going. Okay, so in this case, we are looking for the measure of YWX. So YWX is right here. It is our unknown. In order to find its measure, I have to find its opposite arc. Well, both the opposite arcs, right? But notice this time around, there's actually no numbers there. However, I do see numbers here for these arc measures. And how can I use that in order to solve for my missing arc? Well, think about what we can use, right? So, for example, if I can't find this x here, I do notice that I have an angle here that does have its opposite arcs present, right? So if I was able to find this angle measure, I would be able to find x pretty simply because they're supplementary angles. They're sitting together on a line. They are linear pairs. So I'm going to go ahead and find that pink angle first, and the setup for that would just be, let's call that y equals 1/2 43 plus 81. 43 plus 81 is 124. Multiply that by 1/2, and y would equal 62 degrees. Now, that 62 degrees, keep in mind, is right here. So if I want to find x, which is the missing component, I would have to do one more step of 180 minus 62, and that would give me 118 degrees. Okay, so again, unit 2 material coming back. Always, always, always coming back. All right, so in the next problem, we have to go ahead and find the arc this time. So LK is the missing component, which means I do have the inside angle. So instead of setting it x equals, well, this would have been, my x value. So this is just going to be 62 equals 1/2 times its opposite. Well, I don't know the opposite, so that can be x, plus its other opposite arc, which I do know, and that is 74. So this is where I was saying the algebra review was useful, because in order to get rid of the 1/2, I can just go ahead and multiply this entire thing by 2, allowing for that 2 to disappear. What I do to one side, I must do to the other. This will end up giving me 124 equals x plus 74. I subtract 74 from both sides and get x equals 50 degrees. Okay. All right, let's look at another similar type one here. For question 5, we want to find the measure of arc CDE. So CDE is this major arc right here. I noticed the angle it's opposite is 128, and then the other arc opposite that angle is 73. So again, my setup here is 128 degrees. You know what? I don't want to use pink anymore. 128 degrees equals 1/2 the opposite arc, which is unknown to me, so it's x, plus the other opposite arc, which is 73. Now, if you weren't sure what I did previously, I just want to reiterate here that I want to get rid of this 1/2 in order to start getting x by itself. And the way to do that is its opposite. So the opposite of 1/2 is multiplied by 2, because fractions are just division. So in essence, I just need to multiply this entire thing by 2, which allows the denominators to cancel out. But in algebra, we have to balance our equations, so we have to multiply both sides by 2, ending up with 256 equals x plus 73. Subtract 73 from both sides, and we end up getting x equals 183 degrees. Okay, last one here on this section. So we need to find the measure of QT. So QT is the arc here. It is opposite this angle of U, which is unknown to me, right? And then that is opposite the angle, I'm sorry, the arc 95. Well, this is not that difficult to find out because you might be saying, well, Ms. Shima, here I have two unknowns, right? Yeah, you do. But there is a hint placed here that allows you to solve for this missing U part. So remember, it's on a line, right? These two share a line. They are called linear pairs because they're on the same line. Therefore, I can find the value of U by simply subtracting it from 180. So 180 minus 79 is 101, meaning that the angle U that we're concerned with is worth 101 degrees, right? Knowing that, we can now go ahead and go ahead and continue to solve to find the arc QT. So 101 equals 1/2 times the opposite arc plus the other opposite arc. And again, I want to go ahead and get rid of that 1/2 by multiplying the equation by 2 on both sides. And we get 202 equals x plus 95. I'm sorry, I don't know why I put the parentheses in. And then I subtract 95 from both sides. I end up getting x equals 107 degrees. Okay, and that's it. It is a fairly simple concept. So the next, I've decided I'll just do it video by video. So the next video will be on the circle intersections, and I'll probably just pair that up with exterior intersections as well, and maybe do a few select problems on 5, and then you guys can go ahead and try to solve the rest of those yourself as practice so that you got a lot of examples done for me and you can do the rest by yourself. Okay, I'll see you in the next one. Bye.